In this video, we'll be looking at 5 important questions that were asked in IGCSE Paper 2 2024. Let's get started. In this question, we have a beam that's balanced. So it's not rotating. It's perfectly balanced. And there are 3 forces applied on this beam. 3 forces are P, and a force going up Q, and another force going back down R. If a beam is balanced, or for that matter, if any object is balanced, the moments of forces have to be balanced as well. About this pivot, this force R will try and rotate it clockwise. The force Q will also try and rotate it clockwise. But this force P will try and rotate it counterclockwise. If the beam has to be balanced, the clockwise moments have to balance the anti-clockwise moments. So that's the equation we'll try and write. So the equation which we are after is clockwise moments equals anti-clockwise moments. For clockwise moments, R and Q, both of them are responsible. The moment due to R would be the force R times the distance. The distance is A, plus the moment due to Q. The moment due to Q will be Q times B. That's the clockwise moment part, equals the anti-clockwise moment. That would be P times C. We can rearrange this equation and write it as P times C minus Q times B equals R times A. Okay, if we check our options, we'll find that option B is the correct one. So option B matches our solution. So that's the solution for the first question. Let's move on to the other one. In this next question, we have a liquid that's filled in a column, and we have to find the pressure at the bottom of the vessel. We have to find the pressure at the bottom. We know the equation for pressure is equal to the density of the liquid, represented by the letter rho, times the acceleration due to gravity, which is around 10, times the height of the liquid. Here we have to be careful that the unit is in centimeter, and all of our options, they are in meters, meter cubed. So we need to convert centimeter to meters before we use the formula. So if we convert 50 centimeter to meters, it's going to be 50 divided by 100 meter. That's 0.5 meters. Okay, so with that thing being done, we can use the formula. Pressure is equal to the density times the acceleration due to gravity, which is 10, times the height, which is 0.5. The pressure is given to us. Pressure is given to us as 6,000. So we can use that value here. So that would give us 6,000 equals the density times 10 times 0.5. So we can rearrange this equation, and we'll have, if we solve this, we get 1200 equals the density. And which is the correct option? That matches option B. Okay, so we are done with this. Let's move on to the third one. In this example, we have a block of mass 0.8 kilograms, and we are trying to heat it up. So we stick in a thermometer to measure the temperature rise. What we do is we place a heater inside this block, and we connect it to an electric source. So current is going to flow into this heater, heat the heater up, which in turn is going to heat the block. We have to find out how much would the maximum increase in the temperature of the block be. So what we're going to do is, first of all, we'll find out how much energy, electrical energy, is being transferred to the block. How can we do that? Well, we have an equation that says the energy given, energy transferred by an electric circuit is equal to the electrical energy, it's equal to the potential times the current multiplied by the time. Fortunately, all three of them are given to us: voltage, current, and time. So we can substitute all of these here. So if we do that, let's try and do that and figure out how much that is. So V is 12, current is 5, and the time is 300. This energy turns out to be 1800 joules. So 1800 joules of electric energy is being dumped inside this aluminium box, and this 1800 joules will try and increase the temperature. But how can we link the energy that we are supplying to the increase in the temperature of the block? For that, we have a very important equation that says the energy that you supply is equal to the mass of the object to which you are supplying that energy times the specific heat capacity multiplied by the temperature increase. So we can substitute 1800 here. Mass is 0.8. Heat capacity is given to us as 900 times delta T would be the temperature change. So we can rearrange this. If we solve this, we'll find that the temperature rise is 25. So 25 degrees is the change in the temperature, and we find that here. So C, option C is the correct one. Let's move on to the next important question. In this example, we have a ray of light that is moving through air. It strikes a boundary and goes inside a glass block. The incident angle is given to us, it's 55 degrees, and the refracted angle is given to us, which is 33 degrees. And we have to somehow figure out the speed of light inside the glass block. So whenever you see a question like this in which the angles of incidences are given, we should automatically try and look at it using Snell's law. So what's Snell's law? Let me write that. So this is the mathematical form of Snell's law. N1 is the refractive index of the first medium. Sin I is the sine of the incident angle. In this case, that's 55 degrees. So sine of 55 degrees. N2 is the refractive index of the other medium. In this case, it's glass. Sine R is the sine of the refracted angle, which is sine 33. We can rearrange this equation and write it as so here's a rearranged equation of the same Snell's law. Since we are concerned about finding the speeds, so we want to somehow convert this N1 over N2 into the speeds. What we should know is that the refractive index is inversely proportional to the speed. So what I can write is that N1 over N2 can be written as V2 over V1, where V2 is the speed inside glass and V1 is the speed inside air. So I can substitute this thing in the first equation, and I'll get V2 over V1 equals sine R over sine I. V2, V1 we know, V1 is the speed of light in air. So we can rearrange this equation and write it as sine R over sine I. Now we know how much R is, we know how much I is, so I'll plug all those values inside here. So when I plug all those values, I get this expression. Now we need to solve this. So if I solve this, plug this in my calculator, I get a value of V2 equals 1.9 into 10 to the 8. This is almost 2 into 10 to the 8th. So if you go back, we'll find that option B is the correct one. Okay, so we are done with this. Let's move on to the final one. In this question, we have to find out in which circuit both of the light bulbs are going to glow. Let's start with the first one, the A. In this case, this diode won't allow the current to flow through it. So if there is no current, if the diode is straight away blocking the current, none of those two bulbs is going to glow. So A cannot be correct. Let's move on to the other one. B. In this case, the current can flow like this, but it will kind of get blocked here. So that path is not possible. Similarly, for this one, this path is also not possible. So both of these bulbs are not going to glow. Let's have a look at the third one. In this case, the current can flow like this. So bulb 1 will glow. Current can also take this path. So the other bulb is also going to glow. So C is the correct option. Let's also have a look at the D part. In this case, current can flow like this. So this bulb is going to glow, but current cannot move through this path. So the bulb which is lower is not going to glow. So C is the correct option for this one. And that completes our 5 important questions from Paper 2 IGCSE 2024 February-March session. I'll see you in the next lesson. Take care. Bye-bye.